Hello and welcome to another one of D's ADD videos. Today we're going to be looking at VESPR examples. Alright, so these last two that we have left to do are slightly more complex. If you were to do the Lewis structure for this, you would find that you would have put the single bond on the peripheral halogens. That's what they usually do. And you would find that there are three sets of lone pairs around the central iodine. Iodine being on or below the third row, you can have the expanded octet. Here we have, from the central atoms, all we care about, 1, 2, 3, 4, 5. So right away we should know its domains is 5. Trigonal bipyramidal. And that's for the EPG. And then for the molecular geometry, it's going to be linear. If you take a look, we've got 5. All of them that are 5 have trigonal bipyramidal as their electron pair geometry. And then when we have 3 lone pairs right here, so 2 elements, which are the 2 iodines, 3 lone pairs, it's linear. The bond angles are 180. How do we achieve that linear? Let's look at the picture. It would be this shape right here. The 2 atoms on top and bottom, and then symmetrically 120 degrees from each other on the same plane are the lone pair electrons. But the only bond angle we actually care about is that 180. So let's draw that so we can move on to the next one. So we would have I. That would be 180 between these guys. And then we'd have 2 lone pairs here, 2 lone pairs there, 2 lone pair electrons there. They would all be in the same plane, and you can have those going back out of the page into the back of the page, and then this would be in the plane of the page. Then this could come out of the page. And the reason you don't put bond angles of 120 in between these is because they're lone pairs. There aren't bonds. But these are bonds, and that bond angle is equal to 180 degrees. Alright, so there's your linear, and it's trigonal bipyramidal. Okay, let's look at XeF4. Xenon is a noble gas, and you would expect a noble gas not to react, but it can react with certain atoms, fluorine being one of them. So what happens here, if you were to draw the xenon as the central atom, 4 fluorines, this is the Lewis structure, and you should have the characteristic 3 sets of lone pairs around each peripheral halogen and the 1 bond. And if you do all this, you will see that there aren't enough electrons, so there's 4 more unaccounted for, so we put them around the xenon using the extended octet rule, because we have access to the d orbital because it's on or below the 3rd row. Alright, with all that being said, we now count the domains. The domains, there are 1, 2, 3, 4, 5, 6. And then the bonding domains are 4, and the lone pairs are 2. So the EPG is octahedral. Anything with 6 octahedral, anything with 6 domains is going to be an EPG of octahedral. The MG is going to be square planar. So how does that look? We would have the xenon, the fluorine, fluorine. These would be going into the page. These would be coming out of the page. You'd have one lone pair above, one lone pair below. And then the bond angles for those guys are going to be 90 degrees. Okay? So you can see that a mastery of Lewis structure is required for you to be able to do VESPR theory. And in order to further understand the concept of hybridization, which we will touch upon next. So practice, practice, practice. I hope this has cleared up any confusion that you might have. Make your flashcards and start memorizing the different conditions for the EPGs and for the molecular geometries. I hope I've eliminated any doubts that you might have. Thank you and have a nice day.